Okay, students, welcome to our first of Ed Puzzle. We're doing Unit 1, Lesson 2. You're going to be taking notes as you watch. You're going to take the notes. You're also going to be actively listening. And you're participating. And you're giving excellent and integrity. Excellence and integrity. Excellent work. All right, put your name. I'm Mr. Garrigus. My class periods are 2, 3, 4, 5, and 7. Today's date is 8/25. All right, what are we going to do today? We are going to perform a dilation at the origin. We're also going to do a rotation, 90 degrees about the origin. So this word origin has come up twice. We're going to dilate by a half. And the origin, of course, is the point on a coordinate plane at 0, 0. That's the origin. It's at a location. So we need a location to begin with. We have our essential question. How do you know when two figures are similar? We're going to be exploring that. We talked about congruent before. Remember, congruent means that they are the same size. It means the sides are the same length and the same shape, which means the angles are the same. Similar figures, and for congruent we put this equal sign and a squiggle line. But for similar figures we just have the squiggle line. And what we do know about that is they have the same shape, but they're not the same size. So they have proportional sides, and they have the same angles, which gives them the same shape. Okay, so we're going to be dilating on the coordinate plane, and as you can see in page 487, if you have your textbook, you can go to page 487. You can see that this figure is being dilated from the origin. Now you need to have the pre-image and the image. So in your book, if you see that this smaller triangle is ABC, we'll say triangle ABC. That's the pre-image because it doesn't have the apostrophes, which we call prime. So we have triangle A prime, B prime, C prime, and that's your image 1. Notice we went from a very small to very large. So let's see where this is located. The origin's at 0, 0. There we go 1, 2, 3, 1. 3, 1. And C prime is at 1, 2, 3, 4, 5, 6, 2. That's your C prime. Notice that to go from 3 to 6, it's times 2. And to go from 1 to 2, it's times 2. So we call that a K factor. And what we end up with is this rule. It says symbols here, but we're calling it a rule that if you dilate from the origin, that's the key, then you can just find your new coordinate points by multiplying by your scale factor, which is called K. So it's hard to read here, but it says that for every X and Y, if you want to find the points under the K equals 2, then you would do K times X, which is 2 here, 2X, 2Y. So if I had B here at 1, 1, 2, 3, 4, B is at 1, 4, then I'd get B prime by multiplying 1 times 2 and 4 times 2. So I don't have to count anymore. I can just put the location. Okay. And we're going to talk about mapping figures, which is the answer to the essential question in a minute. Let's take a look at one of the reflections you did earlier. And here we have our original pre-image, which then we translated by this vector here. The vector is this line here. This was a translation, which was the x's and y's were transferred to x plus 2, y minus 8. Okay? And then what we did was we reflected over the x-axis. That was our line of reflection, the x-axis. That was a line of reflection. That got us from image 1 to image 2. And then we reflected again over the y-axis. And this was our new line of reflection. And we looked at the rule there where our x's didn't change, but our y's were the opposite. So we wrote a rule, and then we reflected over that, and we're over here. Now we're at image 3, and we want to dilate. So we're going to dilate by a factor. We're going to dilate image 3 with a factor k equals 1/2, which means for every x, y, we're going to multiply times 1/2. Make this a little bigger here. Okay, so when we do that, we're going to have 1/2 times 4, which is 2. So we're looking for a new point here. We have 4 6 times 1/2. 1/2 of 4 is 2. 1/2 of 6 is 3. So our new point is at 2, 3. We're going to give it some new letters because it's we're going to give it some new letters. So let's call it MN. Well, let's call it D, E, and F. So let's call this point D, and it's at 2, 3. Let's do the same thing for 8. 1/2 of 8 is 4. 1/2 of 6 is 3. So let's go to 4, 3. We'll call that E. 4, 3. And then we'll go to F at 4, 1, because 1/2 of 8 is 4. 1/2 of 2 is 4, 1. Now we'll draw and connect the points here, and you can see that the triangle has the same shape, but it's smaller. It's half the size of the original because our scale factor was 1/2. And we'll call it image 4. And how do we know for sure that this thing is been dilated correctly? Our point of dilation was 0, 0. And if we draw lines through 0, 0 and they go through both points, we know that we've dilated correctly. So I'm going to grab a different color here that I haven't used. I'll try dark green. And let's take a look. Let's connect the dots through the point of dilation, and you do that on your notes. There's one. Let's do another. And we'll do one more. And now we can see that these dilation points all go through here. Now if I had multiplied by negative 1/2 instead of positive 1/2, my image would be on the other side of these dilation points. And you can see as I can dilate by anything I want, I'll stay on these dilation points and they'll go through the center, and anything negative will pop up the other side. Okay. So if we look at our quick little coordinate here, let's take A triple prime, for example. We shrank the object at k equals 1/2. Our rule was x's y's became 1/2 y. And the point is now, and we called it F, and it was at 4, 1. So pretty simple for the dilation. The rule, let's take a look at the next thing. We're going to look at rotations. Rotations about the origin. Now, you got to be careful. You can rotate the triangle clockwise. So clockwise is in this direction. If you were to look at a clock, the clock is here. It has a long hand. The hour hand is short. Let's say it's 12 o'clock. And then you have a longer hand. Well, this is the minutes hand. Clockwise, the clock travels in this way, in this direction. So you need to know that this is clockwise. You have another option, and we call it counterclockwise, would be the other direction. So here we have a situation where we're going to rotate this. We're going to rotate this counterclockwise. We have some rules set up too to do it by rule. Let me zoom in just a touch more so you can see this a little bit better. And we want to take image 4, we're going to rotate it 90 degrees. Okay, I have a simple tool that I can use that will help me do this. You can take any light paper, but this is a hamburger patty paper. It's really good for seeing 90-degree turns. Simply, you can just turn the paper one turn, and that's 90 degrees. You could turn it again 90, 90, 90 until you get back to your original position. There's also GeoGebra, and there's also something called a compass, but this is probably the easiest way to visualize it. Let's take a look. We're going to put a circle on there. We're going to label our points. We're going to do this. So we have a congruent triangle at image 4. And now I'll just put my finger on the origin here, and I'm just going to turn it one full turn. You'll know that the dot has to stay on there. Now I've done a full turn. And now I'm just going to lift up and trace this triangle where it is. You don't have to use, again, you don't have to use patty paper. Now remember, this is 1, 2 units, 2 units. A rotation keeps congruency, so I'm just kind of freehanding it here because of the patty paper. Normally I'd use a straight edge or the side of a Chromebook or something like that. So I have my rotation. Let's draw what's happening here. Okay, let's see. The point here, let's go to this point. This point is called J, and then J rotates, and it rotates 90 degrees. Okay, what is 90 degrees? It's got to be perpendicular. Okay, so this angle from the origin is 90 degrees, and it had a direction. It went, I'm just going to kind of freehand this. So we have a we have a circle, it went in this direction. 90 degrees. So we have a 90-degree rotation about the origin. 90 degrees. We didn't go clockwise, we went counterclockwise. About the origin. And it's a rotation. And then we need to label our point. We'd call this J prime. And this point K went this way, so this is K prime. And then this was L. L went this way, it's L prime. And we need to give its location. Looks like it's at negative 1, 4. And K prime is at negative 3, negative 4. And finally, L prime is here, and it's at negative 3, 2. And then you can look at the points. Well, this point was 4, 1. Looks like they switched, so if I had to write a rule here, where J was at 4, 1, and J prime was at negative 1, 4, then if I had to write a rule for a 90-degree rotation counterclockwise about the origin, I'd say that my x's and y's switched, right? They switched here. The position of x and y switched, so I'm going to write y and x, and one of them switched signs. Did the x coordinate switch signs? Yes. Did the y? No. So I'm going to make this negative x. And now you've written a rule for a rotation 90 degrees. And you can just copy it down here. The coordinate was J at 4, 1. We did counterclockwise, 90 degrees about the origin, and we wrote the rule as x and y, negative y, x. The x's and y's switched, and the point is now at negative 1, 4. Oops, I went off the page just a little bit. Sorry about that. Rule, and there you go. Make sure you call it J prime. Okay, and that's it.